Okay, in this video I will go over the last two quizzes that we had in class as a preparation for the final. We went over the other quizzes in our last review video until this quiz, the chapter 11 or the week 11 quiz. We did the front side, but now I'll do the back side and then I'll do the week 12 quiz. So in this problem, a 95% confidence interval for a proportion is calculated based on a sample of size 20. Which of the following actions would widen the resulting confidence interval? If we increase the sample size to 40, that would give us a narrower interval because, as we know, a larger sample size gives us more information with which to estimate the population proportion P. So it can't widen the interval by getting more data. That means you could widen the interval by decreasing the sample size. We could also not widen the interval by taking a lower confidence level. If we go to 90%, that narrows the interval because now, since we're not going to be as confident, we can give a narrower interval. So it's certainly not C. A biased sample will not change your interval width. It will just make your interval useless, and the interval can be widened. So B is the answer. Number 5 says, when we take a sample of 16 high school students, 12 of them reported using the library. What is the 95% confidence interval for the true proportion of high school students who have borrowed a library book in the past year? Our formula here will be our p hat plus or minus z star. Since this is a proportion, we use z star instead of t star, times the standard error of p hat, which, as we know, is p hat times 1 minus p hat over n. N is going to be 16. P hat is going to be the number of successes, which is the 12 who said yes, over the total number of students we asked, which is 16. That gives us 0.75. So our formula will be 0.75 plus or minus a 95% interval will always give us a z star of 1.96 times the square root of 0.75 times 1 minus 0.75 over n. And I get 0.54 on the low side and 0.96 on the high side. Thus the correct answer is E. Now moving on to the next quiz. What is Z star for a 93% confidence interval for a one population proportion? That is P. We want an interval for P, a population proportion. Z star for a 93% interval will be given by Q norm. Since Q's always give us Z stars and T stars, we want the Q norm, not P norm. And then we have to say what is alpha over 2. Alpha is whatever you need to make this number into 100%. So it's 7% or 0.07. So alpha over 2 is 0.035. Therefore, we need to say Q norm of 0.035, and the answer is 1.812. Like with all Z stars and T stars, we don't care if it's a negative or a positive number because your confidence interval is going to have a p hat plus or minus a z star times the standard error anyway, so you have a plus or a minus. It doesn't matter if this thing is a minus or a plus. Number 2 says we look at 152 smokers and find 7 with psoriasis. We look at 236 non-smokers and find 4 with psoriasis. So what is the value of p hat 1 minus p hat 2? Where sample 1 is the non-smoking group. So p hat 1 is the proportion of non-smokers who have psoriasis. That is 4 out of 236. And the p hat 2 is the proportion of smokers who have psoriasis. That is the 7 out of 152. Which gives you minus 0.03. Part 3 wants us to make a confidence interval for P1 minus P2, which is the difference in the population parameters of population proportions of non-smokers and smokers who have psoriasis. So we need to use a formula for this confidence interval, P hat 1 minus P hat 2 plus or minus Z star times the standard error of P hat 1 minus P hat 2, which we said is P hat 1 times 1 minus P hat 1 over N1 plus P hat 2, N1 times 1 minus P hat 2 over N2. Well, we already found that this part here is minus 0.003. We are given that our Z star should be 1.96. And then we will put in our p hat 1s and p hat 2s into this area, into this region over here, and get the total interval. So minus well, I'll just use what I said last time, minus 1.06 times the square root. My p hat 1 is the 4 out of 236 times 1 minus 4 out of 236 divided by N1, which is 236, and then the same thing, I have 7 out of 152 times 1 minus 7 out of 152 divided by the 152. It is 152, right? Yes. So you get minus 0.067 on the low side. On the high side, you get 0.008. That is choice E. Flipping to the back of the quiz, suppose that a 90% confidence interval for the proportion of children in this younger age group who experience night terrors is this interval, and then a 90% interval for the proportion of children in the older age group who experience night terrors is this interval. Sample sizes were 200 younger children and 160 older children. On the basis of these intervals, is it reasonable to conclude that the population proportions experiencing night terrors differs for young children and older children? In other words, we're questioning whether P1 equals P2. It sounds like that is what you do a hypothesis test for. Indeed, you can do a hypothesis test for that, but we're trying to do it with an interval. We said in class that if the intervals overlap, then you can't be sure that the two proportions are different. If the intervals don't overlap, you can conclude that they are different. In this case, you have from 0.02 to 0.08, and then 0.06 is inside that interval, meaning the intervals overlap. On a number line, if this is 0 and this is 0.02, then you have 1, 0.04, 0.06, 0.08. You have one interval that goes from 0.06 to 0.10, another interval that goes from 0.02 to 0.08, and obviously they overlap. So we cannot conclude that these proportions are different. Is it reasonable to conclude that proportions differ? The answer would have to be no. And since the intervals overlap. Part 5 says, if we have a sample mean, a sample standard deviation, and a sample size, we want the 95% confidence interval for mu, and we have what our Z star is. The formula for this interval, we're talking about a sample mean, or a population mean, from one population. X bar, now here was by the way, I wrote that wrong. That should be a t because we're using means instead of proportions. We always do t's. Therefore, 1.96 would not really make sense to use for a 95% confidence interval, because we would have to find out what QT 0.025 for 24 degrees of freedom. We should be using negative 2.06 for this, so I apologize for the error. Anyway, if we just follow the directions, we'll use a t star of 1.96. So I'm going to use x bar plus or minus 1.96 times the standard error of x bar, which is s over root n. X bar is 144, s is 12, and n is 25. When I put that into my calculator, $139 on the low side and 148.7 on the high side. So the correct answer is D. I hope that is helpful for explaining these quizzes, and that will be the first video for reviewing for the final.